This is a short video on how to build a schema for teaching how to use and edit a formula in a spreadsheet. And what we're going to do is use the principles of cognitive load theory and knowledge space theory, which you won't need to know about too much, and high graphs to do it basically intuitively. So hi-ho. What we start with is a high graph, because that's a good idea. And this is the schema for building a high graph. I'm going to assume that the people watching this are computer literate, that you can handle file management and GUI editing. I think it's really important also that people have domain knowledge. Well, I'm assuming that people are able to use a spreadsheet and do some formal your domain knowledge could be expert knowledge, I just know it, or it could be a syllabus. In this case, I'm going to use the ECDL syllabus just because it gives a reference and a structure. I think if you're in the curriculum design space, then being able to having some teaching experience is important. It's very easy to just do the job, to do it on paper without actually doing the job properly. And then the ability to think like a student, because that's fairly critical in understanding where things fall apart. So there's a little video on high graph basics, and it's kind of what I'm going through here, that we can edit and move graphs around and do stuff with them. And we will get into topic schemas in a moment, but what I want to do next is look at a brief introduction to cognitive load theory. So here we go. I think in models, I think graphically, which I suppose is why I like the tool, and we're going to look at modeling a curriculum, simple spreadsheet formula. Why am I building this model? To teach a difficult or misunderstood topic. You don't need models to teach basic alphabet, basic numbers, times tables. These are very simple. They require a lot of effort, but they are not complicated to teach. For a misunderstood or a complex topic, we're going to look here at spreadsheet formula. That's where I've got my material. And what we will build is an explicit order, which is in which to present the material, so that we have a clear understanding of it, so that we have no gaps, that you can know that the kids will understand. I teach high school kids, so that's what I'm assuming, but that you will have left no gaps as you go along in order to master the topic. It's important to note there are possibly many valid orders of going through the material. We will find a valid order, and you need, yes. So this works off cognitive load theory. The big ideas here are working memory, which is loosely analogous to conscious mind. The idea that we can hold 4 to 7 items in our heads, in our conscious working memory at once. The short answer is it's limited, very limited, certainly less than 10. What's interesting is that an item can be very flexible. Items can be very complex. I can say, as well as example, as restaurant. I say restaurant, everybody understands, as a huge model comes to mind immediately. Soccer game. And working memory is where interactions are all processed. It's where the sensory processing comes in and is fed into long-term memory. And that's a whole big, complex space that educational psychologists are still working on. What we're interested in doing is building a schema in memory, in long-term memory. Initially, everything's held in working memory and takes a slot, one of those 4 to 7 slots, and we need to leave a slot or 2 for actually putting it together. Look at this, look at that, and that requires effort. Ultimately, we can automate a schema. And that's an important concept in that it becomes automatic. We don't have to think about it. It only takes one slot. Reading for somebody watching this, you wouldn't be sounding out letters, you would be reading whole words or possibly whole phrases even, because we've automated it to that level. That requires practice, which brings us to spaced repetition, scaffolded faded scaffolding, and a whole lot of teaching practice that we will be able to build in around the model that we're going to build here. Cognitive load theory says, how do we avoid overwhelming working memory? So what we're going to do here is create an external explicit schema that helps us see the interactions between the elements. We're going to model out elements, break down the teaching process, the teaching pathway into manageable pieces. Practically, some will be learner specific. That's okay, it depends on how you use it. And what we're going to do is using a high graph to create those schemas, which will suggest an order of teaching that's related to knowledge-based theory, and coming out the notion of the dependency versus concept. A dependency is what must come first. Concept taxonomy, what does it belong to? What do we group together? And those ideas will be very important going forward. And so that leaves us here with, we can then look at a schema for building high graphs, which looks like this. So I have here a taxonomy of prerequisites. You can argue whether that's a good word or not, but to be computer literate, you can do file management, you can edit a GUI. To build a schema, you need to have domain knowledge. You need to have some teaching experience. If you're computer literate, the theory is, the hope is that you can master high graph basics fairly quickly. There is a video. If the previous material was useful, you have a brief understanding of the big ideas of cognitive load theory, the notion of limited working memory, semi-infinite long-term memory, which is built from working memory. And that's going to inform our schema for our topic. In this case, it'll be formula in a spreadsheet. And what we're going to do is build the concept taxonomy first, and we're going to build up a set of blobs, and then we're going to draw some arrows between them, which will give us the dependencies. And then we will say, whoops, we've forgotten this, we need that, and we will refine that model, and we will come out with the basis of a course. So that gives us a roadmap of where we intend, or where I intend to go with this. I always find it useful to start with what are we doing. So this is a schema for spreadsheet formulae. I've chosen it deliberately because people find it a little bit intimidating. I can do spreadsheets but not formulae. Or I'm very pleased with myself, I can do formulae. Cool, great. For my content reference, I've chosen the ECDL reference. They've gone to a lot of work beforehand to take all the stuff you could be doing with a spreadsheet and put it into a handful of pages. So they have here this notion of using the application. We are going to jump between these two documents quite a lot. This is how I work. Typically with two screens, I'm just doing it on one screen for now. So they have this idea of 4.1 using the application. I'm going to go over here and put in a blob and say using the application. That's an entire group of ideas, and it's got its references in here. I'm not going to worry about that yet. They then give us section 4.2 cells. And those who are thinking ahead will say, yes, understanding cells is important to being able to do formulae. we'll see that later. I'm cheating. I'm using my prior knowledge of the topic. And I really am going to take something from database theory here, and we're going to talk about atomic data. Atomic data, which is a cell in a worksheet should only contain one element of data. It actually comes from database theory, but we are good and happy to put it in here because that turns out to be critical to making formulae work. I think half of people's problems with formulae is that they get their data structured the wrong way. So there I've pulled in my teacher experience and said, ta-da, there's Chekhov's gun sitting on the shelf, on the mantelpiece. They've got another one here. Good practice. I'm just copying and pasting. We'll plonk this one in here, put in a blob. Whoops, I got that a bit squonk. Let's just delete that. Delete you. Blob. I'll change its name now. I just want to paste in all of this text. I can take that out. Turns out that if you want to understand absolute and relative referencing, this layout matters. So let's call it list layout. Getting that right turns out to be quite important. I am not being terribly consistent with my naming. I can go back here and just tidy things up. Depends on where you're going. Then we come back here. Do I need to edit sort? Nah, that's not terribly difficult. Copy, move, delete, not so important. Rows and columns, select rows and columns. Well, what we can do here is scroll sideways a little bit, make some space. We want to talk about managing worksheets. Oops, Control C, back here, put in a blob. Managing worksheets. What do we, is there something we need here? I'm not going to go into formulae across worksheets. You could add that in later if you wanted to. So no, I don't need too much detail out of managing worksheets. And now we get to the meat of the beast, formulas and functions. So I am going to say, well, let's assume that I've already taught how to use the application. I need to explicitly have taught these ideas here on atomic data and list layout, and I'm assuming you can manage a worksheet, rows and columns. Let's just put a summary of that so we know what we mean. Definitions are great. Selecting rows and columns, and that's enough. Cool. Formulas and functions. So this is the meat of the beast. We're going to give us a great big blob here. I'm just tapping B to get this done. You can use any key, you can just use the buttons at the top if that works better for you. Formulas and functions. This is the beast. So arithmetic formulas, I prefer formulae. Control C, blob. We can go here, arithmetic formulas, and this idea, cell references. And now we're at the meat of it. If I am going to do formulas, I am going to need this idea that we must refer to cell references if I want to, I can put the reference in there. This is the sort of thing where you might want to add in here an ECDL ref. Boom. And I can have a piece of metadata there that gives me my ECDL reference. You're hiding underneath there. If I want to put that in, I can put it in and not display it. I can put a URL in there, I can put anything I like in there. Refer to cell references is clearly important. Now what this doesn't have is that formulas start with an equals. So I'm using here, I'm taking the syllabus and I am adding my thinking, which is arithmetic formulae, start with equals, because that's important. And now I realize, as I'm doing this bit, that I haven't really spoken about data types up here. It was mentioned, I just chose to ignore it. I'm going to jump back, and we've got here this notion of enter a number, a date, or text into a cell. And that is important. And we talk about data types because conceptually the fourth type of data in a spreadsheet is a formula, because spreadsheets are functional languages like Lisp and SQL. So arithmetic formulas are here, and what we can do is, we won't do the references yet. Trundle back here, and I say formulas and functions. Create using arithmetic operators. Okay, so cell references, arithmetic operators. Let's go. Let's put these in here. Make this a bit bigger. I've got references and arithmetic operators. And because some people like it, we go plus, minus, divide, multiply. Kids multiply and divide are often hard for high school kids too. They don't get that intuitively. Let's just add in power. We could honestly make each of those operators, each family of those operators, so addition and its inverse, multiplication and its inverse, and the power operator could each become a topic in here if you wanted to. I don't know. We'll see. If we need it, we can make it pretty later. We can deal with that. They've got a taxonomy here of some, those under formulas, and I can model a bit bigger, go across here. We've got error values, right? So standard error values, let's use error values, Control C. And I've put that under formulas, cool, so we can put it under formulas. Somebody's done the thinking, I don't have a big need to reinvent wheels. Error values, and understand relative and absolute cell referencing. So now we can go here and we can talk about refer to cell references, and I am going to actually do it differently. Now my B went in the wrong place. To do it differently, I'm going to talk about relative and then absolute. absolute. And because not everybody gets it, we can say A1 and then $1. I tell the kids, you think of the dollar as an anchor because it anchors the cell, or anchors the reference better. And then we've got some notion of functions here. We can add in 442 functions, Control-C, give me a blob, there's a blob, and that's functions. We've got your, I think Excel calls them your statistical functions, 4421. So, what are they? Minimum, maximum, just, let's call them basic functions. We don't have to get it right first time. And here we can, I'm going to switch off to automatically showing me descriptions because they're getting in my way and irritating me at this level of detail. I can go here and switch them off manually, of course. Basic functions, so we want blob of some. We are looking at working on bulk importing stuff from Excel or CSVs or things, but we're still early days with the tool, but it's still quite powerful. Minimum, maximum, count A round. Okay, let's go down. There's no one way. Maximum, count. Someday I will have auto layout function in here. Count A. Count A is going to be fun. I'll put it there because ta-da. We can leave off round for the moment, I don't really mind. We've got basic functions and we've got logical functions, which is a nice idea. Logical functions, and we're not going to go there. Logical functions, and we're going to need the blob for the if function. Someday this will support Markdown. It is on my list of things to do. And then here, essentially, spreadsheet formulas. There we go. Saved. It has been auto-saving as we go along, so it's not the end of the world, but I get twitchy. Cool. What we have done now, I think near enough, is built a taxonomy. We have built a set of items which we can work with. We've built a hierarchy. And of course we've got the hierarchy down the left here. We can see all these items. I have not named them consistently with numbering. I can go back and tidy that up. That's not a mission. So the thing is now, in what order do we teach this? Given that we are assuming we are not teaching total newbies, it is useful, I'm just beginning to get this notion of prerequisites, like we did with this, and here we are going to say we assume that you're computer literate. Computer literacy. If you wanted to, the ECDL modules 1 and 2 are relevant. We could decide to say ECDL module 1 and 2. Gives you a formal definition. You can do that, we're happy. in cognitive load theory terms, I would say that that should be automated. Should not have to think about opening a new file or anything. So we come in with the prerequisites and we teach them to use the application. By default, the arrows mean depends on. If I don't have proper notes like you get with UML, but arrows show dependency, and blobs show taxonomy, or the hierarchy of the names. We just use a blob as a label. Using the application, you can use the application basically. Well done, you. And then we head on to the next part. I just need a bit more space to move this around. And once you can use the application, very next thing we teach is atomic data. That to me is critical. My first lesson is opening and closing, and just an intro. Call this an introduction. But basic data management. There. And so we jump into atomic data. Now we have a choice. We can go to these data types here. I normally do it in this order, that will start with text. Type in your name. And then I like to do it that will do a text, and then we'll do a number. Excel is dynamically typed, and then we can do your shoe size, and then data types, and of course here is the magic of high graphs. Is as you're watching this, the alert will know that a date in Excel is actually just a number, and anything you can do with a number you can do with a date. So you can subtract dates and you can add dates. What is cool here is that we see date falls under number down the side there as we do it, and that just helps us keep track of fairly large things, lists of these items. So I would say atomic data, and then I would do it explicitly. I would teach it in this order. I would do text, I would do number, and my little edges here. Of course we can zoom in. I want to make those absolute sized. So I've got number, and once we've got number taught, we can teach date. So we can actually explicitly say that once we've got number, do date, and lay that out however it works for you. That tearing we must fix. And so we've got that. Control S is always your friend. What's that look like? Not too bad. You'll notice here that by implication we have not yet taught Boolean variables. I'm okay with that, because what we need to look at is the load that we're putting. Each one of these represents one unit of cognitive load. And so at this point I've got quite a lot of interacting elements. And once I've got data types, and this applies to all data types, I can go in and say, how do we deal with lists? And how do we make lists behave themselves well? Yeah, you might want to lay that out differently. That's fine. They've got managing worksheets, selecting rows and columns. We're going to need that later. We'd best teach it at some point then, because if you haven't taught it, life could be difficult. And once we've got some basic data management, we can teach that, so we can put that after that, and we can order it. The ECDL is a well-structured syllabus, and so we see it flowing fairly well. Often online courses jump the stuff around and it's not so cool. So now we've taught those, we can look at formulas and functions. We don't actually need to be able to manage worksheets. We don't need this. What we need, what we really need here, was the notion of atomic data and data types. And yes, I'm going to include list layout. And we now get to the fourth data type, which is a function. Let's just turn off the description because we're not using it and it's getting in the way. And so here we go, and we say you are a formula and you start with an equals. And we teach that. And once we've got equals, you can actually, I think a lot of people would go here and say teach the arithmetic operators. We could. I don't think it's wrong, I don't think it's evil, but it's, I like to actually show them very quickly that we're going to use relative addressing. What is important here is we are not talking yet about absolute addressing. Let's just put both of those off, because absolute is quite a lot more complicated. And this is where you're pulling the cognitive load theory ideas in. So what I'm doing now is, if I go here and I flip to this kind of a meta model, this idea of limited working memory, I'm using that to order and refine my model of concept dependencies. And so we go. So I teach relative addressing. I think I am going to choose to teach relative and then to teach the arithmetic operators. Now I gently hate myself because I actually want to do plus and minus. Plus and minus. 1 plus 1, we can do that. And multiply and divide. The reason is I have left off here brackets. The whole, maybe a better way of describing this would be BODMAS or BIDMAS if you are, I think BIDMAS might even be a neater way. We just select a couple of those, pull them in there, because divide doesn't make very much sense unless you understand brackets. So we just add a blob for brackets. So the whole model is being refined as we go. Parens, because brackets are square. Parentheses. And now we do want to be able to see cancel. We do want to be able to see your definition, because we want to put those two in, make it clear, boom. So I'm going to say teach parentheses, because you can't do division without parentheses, because division is not associative. Division not associative. That's a very long word, but we can just move that whole bit of text over there, move you in there, and so we're modeling this whole idea. Someday we'll be able to put a new line in there. That's fine. So we teach plus minus. We can choose then to teach parentheses, and then we can do times and multiply. At some point here we're going to get errors. Errors are normally created by doing things like deleting cells, but I would only start with the error messages once the kids know how to generate them. So we go there and we do that, and we can teach about error values. But we could also go here, and now we can teach about absolute values. But I can't do absolute values. I need to understand rows and columns, my lists. In particular, I need to have a good handle on lists for absolutes. So I'm going to say specifically needed. It's a dependency like anything else, but it's a specifically needed dependency, because if you don't have it, you're going to die. Here, and let's just move you up. That is specifically needed when we get down here to absolute values. And so I might come back and just remind the kids about what is happening with lists, because absolute values of course only make sense when you're dragging something down through a list. And we've got autofill. Not sure where in their syllabus they deal with autofill, but that's highly relevant to being able to do formulas and functions. So maybe what we really need here is just to think about it. I add in autofill. Autofill actually belongs there, and you can spend hours on these models deciding where exactly does something join. And the difference between that and that, this thing we've just done, is the difference between something that makes sense and something that does not make sense. It's the difference when a kid is lost and a kid says, oh yeah, I've got that, and they learn with confidence. So we get to autofill and we add it in there. Once you're confident with that, we can go through here, and now we can start talking about functions. And well, we're running out of time, and I think the idea is becoming clear, and I don't need a video for all of this, but I would do basic function. I would come in here and I would always start with basic functions. Count must always precede count A, and you need to have a good idea about data typing if you are going to do count A. So you might feel the need to plonk this in and add a point here to say, let's be very explicit about data typing when we get to type A, because I would have to say what's the difference between counting numbers and counting how many are filled in. And so I can make that whoopsie. Well, yeah, now I don't know, do I go there or do I go there? Well, that's fine. The model is never exact. And I come here and I would start, once I've got basic functions sorted, I would actually start by teaching Boolean operators. And then I would teach the if function. That might make me a bit different, but that's fine. We teach the Boolean operators, and now we can show the if function. If we get that in the right order, with the right examples, it works. And there we have, in however long we've been recording this, we have a scheme of work and the order and the dependencies to teach spreadsheet formulae. If you can do all of those things, you're good. things you can do with this. You can print it for the kids and say, in order to do the things at the end here, you're going to need to be able to do this. Put a confidence on here. Is this a naught? I have no idea how to do atomic data. I don't know what that means. Or it's rated out of 10. Naught, I don't know. 10, I'm totally comfortable. Actually, I like thinking in a 0-1 continuum, but a 0 to 10 scale does the same thing. How comfortable are you with these? Text I'm good with, numbers I'm good with, dates not so much. Booleans, you see, Booleans only make sense now. So once we've taught Boolean operators, maybe what we do here is we teach about Boolean data types, and we can just add that back into the mix. That we can say, see, aren't we clever? We can do things with Boolean data types here that are really cool. And that then leads us into the if function as well. We could choose to loop all the way back there. Models have to be practical. Why am I modeling? I am modeling in order to know how to teach and to make sure that I don't dive in teaching the operators if I haven't taught cell referencing, that I don't try and teach formulas before I've taught data typing, and that I get my sequencing right, and that kids can see, oh, I need to understand this from that. And that gives us a high graph, schema and taxonomy that you can use to teach. Of a scheme of work, of a schema, a knowledge space actually, for teaching formulae in spreadsheets. Hopefully helpful.